All right, 8.3 is the final confidence interval we're going to talk about. And this is when you're looking for a population proportion instead of a population mean. So Z interval and T interval were when we were looking for the mean of a population. Now, sometimes you're looking for the proportion, like what percent or what proportion of a population want something. So that's what we're going to do now. This is a lot of times what you'll see for election polls, like this percent of people or this 4 out of 5 people agree with this politician or with this vote. So what you'll see here is a point estimate, also called P hat. So that's how we do this P with a little hat over it. X over N. Sometimes it'll be P prime. So you'll see both of these two things, whether it's the book or the test or different online things, both of those things are X over N. X is the number of successes, N is the sample size. So if we said how many people picked pink out of their favorite color, X would be the number of people that picked pink, N would be the number of people I asked. The point estimate would be that middle of the confidence interval. And then your margin of error is the same idea as it was with the other ones. You're just doing it around a proportion or decimal instead of a mean. In the calculator, you're still using stat tests, but now we're doing one prop Z int. So one proportion, we're dealing with one proportion, and they're all Z intervals. So we don't worry about T for this one. T only works when we're dealing with a mean. They're all one proportion Z interval. That's the difference. Regular Z interval is mean. Proportion, you do one proportion Z interval. So then we get in, so let's look at one. Suppose that a market research firm is hired to estimate the percent of adults living in a city who have smartphones. So percent right here tells us, hey, percent proportion. That's a word that gives us a hint that it's different than the mean. 500 randomly selected adult residents are surveyed. So that's our N. That's how many people they're talking to determine whether they have smartphones. Of the 500 people surveyed, 421 responded yes, they own a smartphone. So that's our X. How many people responded yes? Those are our successes. Using a 95% confidence level, compute a confidence interval estimate for the true proportion. Everything else is the same. We're just going to do a one prop Z int. So we go to stat, we go over to tests, but now we go down to one prop Z int. Notice number 5 is one prop Z test. We're not doing a test, we're doing an interval. So we have to keep going to one prop Z int. The int is very important. If you do test, you won't know what buttons to push because it'll ask you all kinds of questions. So one prop Z int, and then we enter the data. X is 421, N is 500, and then our confidence level is 0.95. We go to calculate. And then just like before, our confidence interval is 0.81 to 0.87. So we're 95% sure the population percent is between 0.81 and 0.87. So everything else tracks the same deal as before. We're just following that. It also gives us P hat. In case a question asks you, 0.842. So P hat, if I divided 421 divided by 500, that's what I would get for the middle of that range, 0.842. If you mix up N and X, like if you put the wrong number, your calculator will give you an error. So if it spits out error, check if you mixed up N and X. That's the most common thing that people do. So you try. Okay, 250 people are surveyed. 98 reported owning a tablet. We want 95% confidence. So we're going stat, tests, 1 prop z int. X is 98. Confidence level, or no, n is 250. Confidence level is 95. So we get 0.33 to 0.45. Here we go. All right, let's look at another one. For a class project, a political science student at a large university wants to estimate the percent of students who are registered voters. He surveys 500 students, that's N. Finds that 300 are registered voters, that's X. Compute a 90% confidence interval. Confidence level is 90%. And then interpret. So we're going to start by doing our confidence level. 1 prop z int. So X is 300. N is 500. Confidence level is 90%. So we get 0.56 to 0.64. And then to interpret that, we are 90% sure or 90% confident the population proportion is between 0.56 and 0.64. So we're 90% sure that between 56 and 64% of people are registered to vote. We're 95% sure, or we're 90% sure that all of the real confidence intervals would contain the real proportion. It's another way you could say it. We're 95% sure. So you can use the decimals, you can use the percents, or you could say that all the population proportions, 90% of the proportions would contain the real one. It's another way to interpret it. They're all kind of saying the same thing. All right, so why don't you try the U-Try? All right, in a student polls to see if their school for against the new legislation, there are 600 students surveyed. So that's X. Nope, that's N. I was right the first time. And then 480 are against it, 90%. So stat, tests, 1 prop z int. X is 480. N is 600, 90%. We get 0.77 to 0.83. And interpret. So 90% sure, true percent is between 77% and 83%. Who are against? Because that's what we're talking about. All right, B. In a sample of 300 students, 68% said they own a smartphone. So 68% of the 300, so we have to calculate that. 0.68 times 300. 0.68 times 300. Nope, that's not times. Times 300 is 204. Now, yep, so let's do that. So compute a 97% confidence level, confidence interval. So if they give you a percent of the number for X, you have to figure out what the number is. You can't enter a percent. So let me just show you what would happen. So here for X, if I put 0.68, nope. If I put 0.68, and then I put 300, and then 0.97. it's going to give me an error. It's going to say, hey, something's not going on here. I can't do this. Must be an integer. So I need to change that 0.68 to a number. If I had calculated something and I got like 204.5, you're going to have to round to a whole number. It's not going to let you put a decimal there. So just keep that in mind. So x must be an integer. So you either have to calculate or round. Like if you got 204.6, you would have to round to 205 to be able to calculate the value. So we're going to change this Atlanta to 204, and then it will work. Now it will give me 0.62 to 0.74. So now it will give me that confidence interval that I was looking for. So remember, it has to be an integer, so you're going to have to calculate the percentage and get the number and round if it's still a decimal. Now, in 8.1, we had to calculate the sample size using the standard deviation and the z percents. So we went back and we did that using the formula with n. There's another formula for when we're doing proportions. We didn't talk about a different one in 8.2 because you use the same one for the mean. It doesn't matter whether it's z or t, because if you're a big enough sample, it approaches z, so you use the same one. If you're doing proportions, you use this formula. The biggest difference. The other formula, I'll just write it here again really quick so you can compare the difference. They both have z. This one just says alpha over 2 because you're going to split it in half. They both have e on the bottom. The biggest difference is with the other one, you know the standard deviation. With this one, you don't. You're using percents. So the biggest way to choose is if you know a standard deviation, use the standard deviation formula. If you don't know the standard deviation, then use this formula. So it's just use the formula that has the information you need. Like if you don't know the information, use the other formula. You'll be given both on the note sheet. For this formula, p hat is the probability from a previous survey. If you don't know it, use 0.5. Q is 1 minus p hat. If p is unknown, use 0.5 for both. And that's fine. Okay, these are going to be the same numbers as before. 1.645, 1.96, 2.33, 99%. Oh, that's hard to read. 99% is 2.575. And then for any other percent, if for some reason you're given a different percent, just use inverse norm. Put the percent as the area. The mean is 0. The standard deviation is 1 to get the z. But then you just plug them in. Just like before, you always round up. This is to get the sample size, the number of people to ask. So let's look here. Suppose a mobile phone company wants to determine the current percentage of customers aged 50 plus who get text messages on their cell phone. How many customers should they survey to be 90% confident that their estimated proportion is within 3 percentage points of the true population proportion who use text message on their cell phone? So we're doing percents, so we know we want this one. 90% tells us we want our z to be 1.645. So now we're going to plug it in. So Z is 1.645 squared. We weren't given a p hat, so we use 0.5 for P and Q. That's the rule over here if we're not given a p hat. And then margin of error is 3%. So 3% is 0.03. Then we type that in the calculator. 1.645 squared times 0.5 times 0.5 divided by 0.03 squared. We get 751.7, and we always round up, so we would ask at least 752 people. That's all that's doing. So p hat was not given, so we use 0.5, and then q hat is 1 minus 0.5, so we use 0.5. That's where I got these two numbers right here. All right, so why don't you do the other you try? They want to determine how many current percentage. They want to be 90% sure. 90% goes to 1.645. How many customers? 5 percentage points. They don't give us a p hat, so we use 0.5. Q is 1 minus 0.5, which is 0.5. So then I plug those in. 1.645 squared times 0.5 times 0.5 divided by 0.05 squared. 0.5, 0.5, 0.05 squared. So we get 270.6. So we would ask at least 271. So that's 8.3. The biggest takeaways from chapter 8 is your parameters. You're either dealing with the mean or a proportion. If you're dealing with the mean, you either know the standard deviation or you don't know the standard deviation. If you know the standard deviation, you're going to do z-interval. If you don't know the standard deviation, you're going to do the t-interval. If you're dealing with a proportion, you do the 1 prop z int. Those are the 3 things for your confidence intervals. The calculator tells you what else to put in. And then the 2 formulas to get sample size are, if you know the standard deviation, use this one. If you don't know the standard deviation, use this one. And if they don't give you P, use 0.5. Those are the biggest takeaways from this whole chapter. So let me know if you have any questions.